Hello, this is Goto. Welcome back to Feed the Beast Interactions Remastered. Today I have set up a new multi-block since last episode. I set up the multi-block mixer, the large mixing vessel. Like the laser, I've given it 32 amps of IV power, even though it can technically only use 16, but it has those two 16 amp patches on the bottom. And it can do ZPM voltage at LUV recipe, 4 parallels, so pretty nice. I mixed up some tungsten steel in it, and it's just lightning fast. Here, actually, I can mix up some more tungsten steel. Let's see, just checking that we have enough tungsten. Okay, let's just see how fast 32 dust is, right? All right, there it goes. Wow. There's one already done. There's two already done, and it's also doing it in batches of 8 because I took the parallels and I multiplied them by 8. So, or not by 8, by 4. So I tried a few different methods about setting this up. Originally, I had a bunch of different input buses, and then I had a bunch of P2Ps going into all the input buses. I was like, okay, maybe if it puts all of the different recipes and all the different buses, it's going to kind of take all of the buses of the, not the buses, all of the recipes of the same kind and run those on a parallel. But that's not how it works. It will run when you have it set to distinct buses mode. It will just run one operation per bus. It's not going to look to multiple buses to combine them, even if they have the same recipe. So down below we have the one bus that has the circuit setting mixer recipes in here. And then over here in the corner, I have an interface touching a quadruple input hatch and a input bus with no circuit in it. And that runs all of our other mixer recipes, such as just things that don't use program circuits and things that use fluids. So, like indium concentrate, nitration mixture, the elemental dusts, quartz glass. The mold block is in there because that's needed for quartz glass. So, yep, that is the mixer automated. Some noteworthy dungeon loot. Here, let me put this up on a different window, actually. All right, I went to the dungeon and I took a screenshot of the loot. So this is actually here in the top left corner is a screenshot of the loot, so I can't mouse over it. But we did find 4 constellation papers. They're blank, so whenever you pick up a blank constellation, it actually gives you one that you haven't discovered. So that was kind of nice. I might run around Aurelia a bit longer to get more of those, and we can fill out our constellation book. The ones I found are... Where's my constellation book thingy? I think it was Avorix, Ulteria. Why do we have 2 Pelotrios in here? Like, we don't need those, right? Gelu and Horologium, I think were the ones we found. And Alcara. Oh, I might have found 5, actually. Anyways, we found those. And I guess they get sorted when I close this interface. That's why they were out of order, because I had pulled them out before. Anyways, we found a few Wyvern cores and Draconic cores. And these, like, aren't too horrible to make. These do need Draconium dust. But we can actually make Draconium dust, so Draconium dust is not, like, out of reach for us. We can't turn it into ingots, though, because we need some higher tier coils, but we can, in fact, make the Draconic dust. Been able to for a while, actually. And then an LUV circuit is just a bunch of materials, of course. So we have a few Wyvern cores that I found over there, some Draconic cores. I found a creative capacitor for cyberware. So that's just like an infinite power source for cyberware. And that's something that I could... Why don't I just go like put that in right now, actually? Here, it's been a while since we did cyberware. If I can remember where it goes, we need to take out our current capacitor and stick that in there. I don't think our capacitor's in my knee. Hold on. Let's see, is it in here? Here it is, salvage internal battery. Can we just take that out and then put the creative capacitor in there as well instead? Oh, let me maybe heal a bit before I jump in there and just get killed. Alright, that should be enough to survive. Alright. And now we should have the creative capacitor installed. Alright, nice. There we go. Hooray for us. So that is a thing that we got in the dungeon loot. We also got some dislocators, which are Draconic Evolution teleport items. You can kind of teleport wherever you want, but we've been sticking more with the Astral Gates. We'll be able to make an advanced dislocator soon, once we can make Draconium ingots. But the dislocator is used for a couple things. This Latticite chicken, if we decide to make that. I also found some Neutronium. So we can't really do anything with these nuggets right now. I mean, we could make Endist Pearl, which I don't have a reason to. That's just like a big hand grenade, basically. The creative capacitor, which we don't actually need at this point. Actually, the creative capacitor was actually kind of a huge find, because normally you'd have to make this ultimate battery, and this ultimate battery is horrible to make. Like, look at this recipe in here. Needs neutronium even, and it's not the neutronium that we get from these ingots, it's the neutronium that you have to get from fusion. Anyways, with the nuggets, we'll be able to make neutronium blocks soon. And with the neutronium blocks, we'll actually be able to potentially... Wait a second. Oh yeah, this is Infinity Catalyst. We'll be able to make Infinity Catalyst soon. We can do some other recipes with it soon. Anyways, I also upgraded my sword with some of the creative upgrades I found. So now we have... The sword now has Necrotic 5, and then Sharpestest, which is like Sharpness 5, I think. So it does more damage, and we get more lifesteal off of it now. Unfortunately, we can't get it past luck 3, even though our other sword is higher luck. Anyways, that was the dungeon loot. Oh, and then also a quantum tank we picked up. And then some, both 64k ME fluids, storage. So 15 of those, and then 16k fluid storages, which are just nice to have because they're just like a lot of raw materials mostly. Anyways, enough about dungeon loot. I went mining on Aurelia as well, and in order to do that, I upgraded my drill. So I now have this tungsten carbide drill, and it is a IV tier drill, and it can do 9x9x9 cutting area, which is actually insane. It's like a huge amount of blocks. Let me go show you what it looks like on a real vein. So this is like a vein of lapis and sodalite and aqua. Let me just hit it with the drill here. Yep, just like delete the entire box of 9x9x9. That's just a ton of blocks here. Let me go ahead and get all these ores picked up. Since I mined them, might as well grab them. So that was a big upgrade. And then also, oh, while I'm out here, let me also show you the Prospector. I upgraded the Prospector from LV to the HV one. And the HV one is just a bigger radius. So here we can see a radius of 4 chunks, or 3 chunks, I guess. So we can see all of these veins around us without having to go all the way out to find them. No vein over here, apparently. But yeah, that was just helpful in scouting the planet, because I was looking for a few different kinds of veins over there. Namely, Naquita veins. I got some Naquita, and I've been processing it. So over here in Naquita, there's some Naquita ore, some enriched Naquita. I actually want to do the enriched Naquita in the next tier of ore doubling, which we haven't quite set up yet, but the next tier of ore doubling is, what's it called? So normally you do... Here we go. There's basically 5 tiers of ore doubling. So this is the basic one where you do the dense Naquita ore, and then you macerate the clusters. Then we've been doing all the way up to the crystals, which is the 3rd tier. The next tier you could do is putting it with UU matter, which we haven't made yet. But once we get UU matter, we can do this to double the ore again. And then there's one more step you can do to put it in a Thaumcraft crucible with Desiderium and Potentia, and that can double it further. So you just get like insane mileage out of a single ore. And I'm gonna want to do that with our enriched Nakoda because that's kind of a more limited material, and we're gonna need it for eventual. What are we gonna do with that? This recipe here, Nequadratic fuel, Nequadradiac. I don't know. Anyways, that is a denser diesel, and when we put it into the LUV diesel generator, I modified this recipe, by the way, we can get, this is the same efficiency as the extreme combustion engine, but it just processes more at a time, so it's a little bit denser. 16 times as dense for this kind of fuel. But yeah, this 1 millibucket of this fuel is 44,000. So with the double efficiency of the extreme combustion engine, it's almost 100,000 per drop. So 1 bucket of that fuel is like 100 million EU, which is pretty crazy. As opposed to right now, 1 bucket of this nitro diesel is just 2 million EU, so it's like 50 times more dense. Yeah, you can see it right here, 2,500 to 44,000. It's a crazy jump. We can also do the Nequadratic fuel in the extreme combustion engine, however, and the LUV diesel generator can also do the infused nitro diesel. Again, this is the same efficiency as the what's it called? It's the same efficiency as the extreme combustion engine. I just modified the recipe because the recipe was left unmodified. So yeah, and it's more oxygen, actually. Technically, this needs a lot more oxygen per second. But anyways, so processing Nakoda. Let me put this drill away before I really destroy my base. Because we're going to need some Thaumcraft stuff, I did do some Thaumcraft upgrades. So I made this ritual over here in the blood magic area. This is a new ritual, the one that's down here at the bottom, and this is something that turns not warp. It turns flux in the area into will, so we'll be able to use will to grow crystals, and I'm going to plan to have like a little bit of Thaumcraft stuff underground here in our basement to be supporting that ore processing. And I also went over to our Thaumcraft area and I added the same ritual over here. So this just keeps the flux at bay when we are doing infusion stuff. Mostly this essential smelter generates flux. So if we look at our map over here, I turn on the flux display. We can see that these areas are pretty clean from flux. It's probably just showing 23 flux because I haven't updated in a while, but this should be 0 flux in all 3 of these chunks here, or all 9 of these chunks. To go with that, I also went and I crafted the on-warping grimoire, which will make it so when we get warp, we can just pop that and it's going to clear all our warp. And you know what? Why don't we go ahead and do that? So we have... Don't we have the Thaumcraft Tome of Knowledge somewhere? So, let's see. Here we go. Ancient Thaumonomicon. This unlocks all of the research, but it's going to give us all the warp. However, this is going to clear all the warp. So, there we go. We now have all of the research unlocked, and your warp has been set to 0. Yay. Way to get all the research and then skip all of that in one foul swoop. So that just required me getting, I needed to get some pixie dust, so I summoned the pixie via roots. I used the roots summoning ritual, and then you can catch it in a jar and you can put a hopper under it. That's what's happening over here. It's just a pixie on hopper, and it collects some pixie dust every so often. So there we go. That's what we did with Pixie. That's what our Thaumcraft progress was. Creative Learner, oh gosh, this is going to be popping up for a while. Creative Learner was just a simple recipe in our assembler, and this just lets us get the Ender Dragon data model And it also lets us level up these data models at will. So I used that and I upgraded a bunch of data models. Here where we had our extruders, I went ahead and swapped them out with simulation chambers, hooked up some clay over here. I have it turned off right now. But here's our Ender Dragon data model, and we look in our system. Sorry for all the pop-ups over there. We now have a bunch of Ender Dragon matter. We have more Wither Skeleton matter, Blaze matter, Thermal Elemental matter. Gee, these researches are really popping up forever, aren't they? Yeah, I mean, that's like all of the research in the game popping up, so that's going to take a while. I could probably log out of it and probably clear this from happening. Creative Learner, and then one last thing I just wanted to mention. You might remember, probably don't remember, but down here a long time ago, I was using sodium hydroxide to make sodium bisulfate, and I changed the recipe. Instead of using sodium hydroxide, because we now need that for other chemistry recipes, I changed the recipe to instead use sulfuric acid, because sulfuric acid is, not sulfuric acid, to use salt, because salt we can get in infinite quantity from brine processing, and we need a lot of sodium persulfate for circuit boards. Anyways, I'm going to pause and be right back, and then when I'm ready to record the next part of this episode, I will do that. So be back soon. Oh, and right as I paused the recording, the thing stopped popping up. That's funny. Anyways, I will be back when I'm ready to record the next leg of this. Alright, back from my little break there. So today I was thinking to work on the next major progression, what's it called, multi-block, which is going to be the assembly line. So I've already cooked up the assembly line controller, and we have a controller casing over here. So this is the assembly line, and it is a machine with multiple slices. I kind of went over it before, but there's these inputs along the bottom, and then there's a fluid input hatch that goes on one of these sides somewhere. Don't think it even matters where the hatch is, but the input hatch goes along the side, and then the middle has these ULV input buses, and then the back has a output bus. So you have to put one item per slot here, and then it will do the recipe using all of the items from all of the buses at the same time. In addition to that, so the controller goes up here, and it has to be up here, but you can rotate the controller, I believe. Yep, thank you for that. You can rotate the controller, so if we want, we can have a assembly line that's standing up, or we can have an assembly line that is laying down. I'm probably going to do them that's laying down just so that they're easy to access, because all of the accesses are on the bottom of the multi-block, and then the power is on the top of the multi-block. So I'll probably do that just to make it easier to access. In addition, they have to have these data access hatches, because in order to do the recipe, not only do you need to have the assembly line and the items in it, but you also need to have what's called a research done. So if we go and we look at the data access hatch, it just holds research in it. I guess we can't see that it holds research, but we have to get these data sticks. And with these data sticks, we need to basically scan an item, and then it's going to give us the data for the item to make with that item's data. So for example, the IV electric motor, when we scan that with a data stick, it's going to give us the construction data for the LUV electric motor. So we're going to have to do that for all of the components that are made in the assembly line. Every single one of these has to have a data stick in here. And if you notice, there are 63 of these so-called recipes. I don't think we're going to be doing all of them. Probably just going to be focusing on what we need to finish our quest here, get the creative key. That's going to kind of be the end goal of this mod pack, is just to get the creative key, because beyond that it kind of gets... I mean, you're going to have infinite items. It's going to be a little silly at that point. And then we're gonna get the LUV diesel generator as well. We're gonna get the 0-point matrix. I don't know that I want to get the 0-point matrix. It's kind of like, why would we want this? We can use this to turn enriched Naquata into enriched Naquata, but why would I not just... Actually, there is some merit in this, because we could turn enriched Naquata dust into liquid enriched Naquata without actually cooking it into an ingot and then extracting from it. So there's some merit there, because cooking it into an ingot costs not an insubstantial amount of energy. It's not that slow, but this is kind of a lot of energy. However, this is 500k energy. And what are we looking at this one? That's 5 million. This is 500k, but it's less. So actually, it'd be faster, but not really that much more energy efficient. Anyways, that's a down the road thing. Today, let's focus on the assembly line. So for the assembly line, we are looking at, we're going to need laminated glass. We're going to need great machine casings. We're going to need assembly line casings. Uh-oh. I didn't make any of those. I made some of the other things, but I didn't catch this recipe here. Let me go ahead and put this together. So assembly line casing, can we make those now? I think we can't make Ruridit gears yet, so yeah, Ruridit. Ruridit ingots, I believe, is something that we craft over in our blast furnaces over here. So 3 ingots takes 30 seconds, 10 seconds an ingot, not that bad. But we do need to make them into gears. Everything else here we know how to make, so let's go ahead and make a quick extruder recipe for that. Gear. Alright, so we should be able to make those now. Assembly line casings. We sure can. Okay. So those are able to be made now. Let's get laminated glass going. So let's just get like a bunch of those. We're going to need a bunch of them eventually. Great machine casings are pretty inexpensive. Let's just make like maybe not that many. That many? And then assembly line casings. How many of these do we need? Right now, I am thinking to make an assembly line that looks like this, of 8 length. So we're going to need 8 assembly line casings. So let's go ahead, assembly line casings, 8 of you. And then we can also request a bunch of solid steel machine blocks, right? Yes, solid steel. Let's just get like, I don't know, a bunch of them. We have the iron to spare, so. Do we have the iron to spare? Hold on. How's our iron? Iron's like 7,000. I mean, it's a good amount of iron, but it's like not like far from unlimited. So yeah, there we go. We have just requested all this stuff up. It's going to take a while to make all of the Ruridit over here, and then whatever else it needs for those frames. But let's go and scope out a place where we're going to want to build them. I think so. Assembly lines are one of those things that is good to parallelize, because if you're going to be making motors in here, and like, look at this, each motor with the IV recipe at least takes 30 seconds to make one motor. It's kind of slow, right? Also, this is some expensive stuff here. We have to have a bunch of HSS, which is a pretty slow to craft metal. That takes, we're using the arc blast, or the alloy blast smelting furnace recipe here. So that's, this makes 9 ingots, and the base recipe time is like 300 seconds, 5 minutes for 9 ingots. We get some free overclocks because we have... Actually, we don't get any free overclocks yet. We're still at HSS gears. We'd like to get up to the next tier of coil, and then I think we might get overclocks. Let's see, we're currently at 5,800. To get overclocks, free overclocks, we would need to be at 6,800, and I think the coils are only going to boost us by 900, so we would need to also tier up our voltage a bit. Then we would get free overclocks. But anyways, yeah, so these are going to be slow to make. And also, data access hatch. We can only have the data for a specific item in an access hatch, but there is something here called the optical data reception hatch that we can have instead of a data access hatch. And what that allows us to do is use these optical fiber cables to get our data from something called a I think it's called the data bank. Data, yeah, the data bank right here, one word. So this data bank can hold a bunch of, on the backside, it can hold a bunch of data access hatches here. So we can have as many of these as we want back here and hold all of the data we need. And then we can transmit it to multiple multiple assembly lines so that instead of having one assembly line, one assembly line with all of our recipes in it, we could just have our data bank holding our assembly line, and then that's going to all of the different assembly lines. And yeah, we're definitely going to have multiple of them because they're going to be so slow if we just have one. So I'm thinking to have probably do them over here-ish. This seems like a good place. So we could have like a row here, we could have a row here, we can have a row here. So that's where I think I'm going to go ahead and start our assembly line construction. And I'm also, what else is still cooking over here for the assembly line? I get some random tools out of my inventory. Get this hammer out of here. Get the splint and steel out of here. Get this quartz knife on my tool belt. Get this probe on my tool belt. All right, it's good enough for now. What are we still making over here? So it's still doing the laminated glass because we opted to do just keep using the elite forming press instead of making an entire multi-block just for the forming press because screw that noise. Okay, so the assembly line casing is done. Just working on the... I guess some ingots were in the EBFs now because now it's doing the steel to make the actual solid steel machine casings. And those are very fast, so... I'm actually like looking at this to see if I can see what the bottleneck is. There's not really much of a bottleneck. I mean, that's how fast the lathe and bending machine go. Actually, it is putting the items in here kind of slowly. That's kind of odd. Which processor is this using? Huh. It's kind of weird. It's doing those plates so slowly. Like with the 64X co-crafting unit, I would expect it to be doing this much faster. Whoops, I didn't mean to hit cancel there. Oh well. Crafting's canceled all. Yeah, it says 64 co-processors. Not sure why it does it so slow, but eh. Okay, so let's get the stuff we need for our assembly line. So laminated glass. Oh, we also need ULV input and output buses. So ULV, I don't think I have made those yet. Okay, we have ULV machine casings. Let's get the input and output buses. So bus. So the input bus is going to, of course, be this, and we can just use... The fluid here we use doesn't really matter. I'm just going to use PBI because it uses 4, and that seems like nothing, so... And I need to put it up here, so polybenzimidazole, 4 of those drops. Alright, assembly casing, go in there. Next, we are going to do the output bus, which is going to be that. I'm just going to craft it in here. And then let's get some ULV input and output buses. So we need like, we're going to need a lot of, well, not that many maybe, like this many. We're going to need a lot of input buses and then a handful of output buses. So, I mean, eventually, not on this particular one, but we will need them eventually. All right, well, we already have a few of those, so let me grab them. And we will be needing some energy input hatches. Since these machines do not accept parallels, we're just going to go ahead and do regular IB energy input hatches. So let's order up 2 of those for our 1 assembly line we're making at the moment, and let's start putting this thing together. Let's go ahead and grab our solid steel casings. We have our laminated glass. We have our ULV buses, assembly casing, and control casing. All right. Oh, and we completed a quest apparently. Cool, I guess. Oh, hey, there was a quest here we can take for some tungsten steel frames and nakoda doped wafers. It's like, cool, you made an assembly line, except not really, because half of the battle is all of the controller blocks. But we cooked those up pretty quickly, you know? IV holes, some nanoprocessor EV circuits. I mean, I'll take them. Okay, so we want our assembly line kind of standing up. So let me put it in line with the vacuum. Actually, we're gonna have the data bank here. So let's make sure, let's have the data bank be aligned with the vacuum freezer. So we'll say the front of the data bank's gonna be here, and then let's have like some spaces here. So let's start our assembly lines like here. All right. So that's gonna be our assembly line. Let's put our controller right here, and then we can shift click it. Oh, right, it goes that way. I don't think I want it going this way, though, so let me just move it over 1 block. And turn it back that way. Alright, yeah, that's how I'd like it. So we have inputs on this side, running down, and then we will have the energy on this side. I could also like have it standing up, to be honest. But I don't have an easy way of flight, so for now I'm gonna leave it like this. Need to invest in creative flight at some point. Invest time in deciding which creative flight we'll use and all that fun stuff. All right, so the input buses are going to go here. We're going to be doing 8 slices, so 1, 2, 3, 4, 5, 6, 7, and then the output bus. And then we're gonna, oh yeah, I forgot we're gonna use a quad input hatch. We have a quad output hatch here. Let me just convert that one. So there's where our fluids are gonna go. Bloop. All right, and then fill that all in. So for the next layer, we need to do laminated glass and then a assembly control casing. Can you like control how many layers this is giving us? It's only giving me the first few layers. Oh well, it's fine. I mean, I know how to build the multi-blocks though. Okay, so we're doing those, and then we are doing these, and then these guys, and then we have to get some grate casings. They're not great, they're just great, you know what I mean? Great, but not great. Never mind, it's a joke. All right, assembly controller blocks. All right, and then the rest of our laminated glass. Wait, no, we're done with laminated glass. What goes up here? Grate casings, that's right. Except the data hatch is going to go right there. Assembly line, I don't think... It doesn't matter where the data hatch is. It doesn't matter where the data hatch is. The data hatch just has to be somewhere along the same line as the controller, it looks like. Okay. So we're gonna leave our data hatch room here to put our data hatch. And then on the top, we are going to put our ivy energy hatches. And the rest is solid steel casings. And then the only thing we can't put a grate casing here because it needs a data access. So this is not going to count as a multi-block. We need to make a data access port for it. Let's go ahead and request that data access hatch. So there's a couple tiers here. There's one with 9 slots, and then there's one with 16 slots. Once we make the data bank, we'll definitely want to make the 16 slot one and then have the 16 slot ones there. But for now, we can only make this one. So we're going to go ahead and make this one quantum chip. Wait, of course, it has a fluid in it, and I always forget to put it in the correct assembler. There we go. So this is going to go in assembly. And then data stick, I don't think I have automated. Let me go ahead and automate this. So this is just a pretty simple circuit assembly recipe. I have put it in the wrong grid again. Here we go. With the liquid soldering alloy. Okay. And then, do we know how to make these chips NOR and NAND? NOR. We do know how to make NOR chips. Do we know how to make NAND chips? We know how to make the wafers, but not the chips. Okay. So let's go ahead and do the wafers. So cutting for the wafer, and then circuit assembly for the data stick. Okay, let's go ahead and make sure data stick works. Throw in a bunch of stuff together. Yep, that seems to have worked just fine. That is the data stick in there crafting right now. All right, so then we can go ahead and make a data access hatch. I'll wait until the stick is ready so that I can use that stick that just got crafted. Yep, to craft 3 more of those. All right. While that's crafting up, I'm going to step away for one moment, and we'll be back when that is ready. Okay, data access hatch is ready. Let's go slop it in there. Probably should have also started scanning some stuff. All right, well, it's sideways here. It doesn't really matter the orientation, but this is the, Actually, is this sideways, technically? Let me see. Normally, you'd have it like this. Yeah, standing up. So it's just sideways from this perspective. I guess it's not technically sideways. But yeah, our data access will go in here, and then when we get the, what's it called later on? When we get the optical cables to transfer data, we can just plug it into the optical data port, which will be in replacement of this hatch. But for now, we need to make some data sticks to actually get some data recorded. So let's make 2 things. Let's make some sticks. Let's make, like, I don't know. We're probably just going to start with the LUV components. All of these are going to require data sticks. So this is a data stick. This is a data stick. This is a data stick. It's actually rather annoying if you think about it, how many data sticks there are. Also, this thing requires 7 circuits for 1 robot arm? Yeah. Don't even get me started on the emitters and the sensors or the field generators. Oh, buddy. That actually requires less circuits. Shut up. Anyways, so let's go ahead and do 5 data sticks for now. 5 of those. And then we're also going to need a scanner. So scanner is what we use to extract the data from the item into the data stick. So I'm just going to go ahead and make an IV scanner. That's going to take a minute because we are making an emitter and a sensor, and those take quantum stars and radon stars and all that fun stuff. Quantum star is a radon star. Yeah, our chemical bath is slow. I'm considering the chemical bath for these recipes, but I'm also considering it for ore processing, so I'm considering a lot of stuff for ore processing. If we have the next 2 tiers of ore doubling, Mostly, I'm just mostly interested in having it for the Naquita, enriched Naquita, I think, because you don't get a lot of this from the veins compared to um, other Naquita, regular Naquita. So at the moment, I'm just considering that for that. So, right, so our data sticks are done. It's working on the actual scanner pieces now. Scanner we can just toss up here. It doesn't matter where it goes. Interface-wise, we're not going to put an interface on it. That's going to be a manual machine. Actually, let's toss it here if we don't need an interface on it. It'll also be a little bit closer to our terminals here. And can you guys also hurry up a little bit more, please? All right. Scanner is ready to go. Toss that right there. Hit plug in, okay. So now we need IV stuff. So let's make an... I'm just going to start with the basic components for now. So we're going to do a... where's conveyor belt? There it is. So we're going to do a robot arm. And then the pump. And then the conveyor belt. And then a piston. And then finally we'll do the motor last so that it wouldn't try to like steal the motor that we, requested there. And all of these should be going fairly quickly with the parallel hatches. Gee, I might want to, like, just get some qubit CPUs crafted on the standby, because it's always taking so long to make them. Qubit. There you go. Please, like, just get 32 of those. Yeah, thank you. And then also nano. Let's get a bunch of nanos as well. 32 of those, please. You'll just absolutely slam the chemical reactor and chemical bath for a while now. Alright, so robot arm is done. Let's go ahead and... Can I do by number of items instead so I can actually see what I'm looking at? Or maybe I can't. I don't know. Our organization of things in here is getting a little hard to find things. Alright, so we have the pump. Let's go ahead and do the robot arm. Oh yeah, I need the data stick. 5 data sticks. So the data stick goes in here, and then the thing we want to research goes in here. So let's do piston. There it goes, and it's pretty quick at least. It's only 15 seconds per item. If we were doing it in the EV scanner, it would be much slower, but we picked the IV scanner for the speed mostly. So what do we put in there? The piston? Piston, okay. So we have piston ready to go. Let's get the conveyor belt and the other thing. I can accelerate this by 1 tick, and I could put the Lapatronic energy orb if I really want to accelerate this. Alright, there's the robot arm data. We're doing the conveyor belt data. Just going to go full unhinged on this battery right now. Okay, so we have motor, pump, robot arm, electric piston, conveyor belt. Okay. Toss those in our assembly line. Data access hatch. Can't really see it when it's turned that way. There we go. Alright, so now the assembly line knows what these things are. We also need a flux point and a stellar cable. I'm just going to have the flux point here for now. Flux point right there. They call it the AST line. I didn't make that up. That's what they actually call these multi-blocks. So, there you go. All right, so assembly line is ready to go. Now all we need to do is bring the items over. So how are we going to do this? And then if we have multiple assembly lines, how are we going to do that? Well, we're going to do something called... it's essentially called... we're going to be using the point-to-point concept. But we're going to be doing it with the assembly line, and we're going to be using the subnetwork of our, what's it called over here? We're going to be using the subnetwork of our assembly line to actually put the stuff where they need to go. So normally in the assembly line, you have to put these items in the assembly line in this order in these slots. So this has to be in slot 1, that has to be in slot 2, etc. And then same for the fluids. But in this version of the mod pack, if we go to GregTech config, we look at machine options, ordered assembly is actually disabled here. So whether the assembly line should require item inputs to be in order, it is off. So we do not have to worry about that, thankfully. So we only need to worry about doing the point-to-point insertion into these assembly lines. So how we're going to do this is that we're going to have a input into this assembly line. And then that input is basically going to be a subnetwork. So let me get a... I was thinking over here, we have this this wireless connector coming over here, and it's only providing 4 channels. I'm thinking instead we can take some channels off of this network here, which is getting 19 channels, give the 4 channels over there, and then that's a slightly more productive use of channels. And then we're not wasting energy just sending 4 channels over here. So let me really quickly grab some smart, wrong place, smart cables. And I'm going to just run this over here. There we go. So now, kind of annoyed that I didn't center it with that one, but that's okay. Nah, let me fix it right now. It'll be okay. Whoops. And then I took a stone brick out of the ceiling on accident. Alright. I'm like, alright, let me just fix it now, or I'm never gonna fix it, probably. Alright, there we go. Now it goes in a straight line, and it comes up, and it goes up there. So instead of getting those teleported channels over there, it will... Here, let me break this one as well. It will go ahead and take these 4 channels from the wireless here. And I did a similar thing over here with the mixer. I didn't give the mixer its own wireless channels. I just pulled over a dense cable from there. I was going to have more channels in here with more buses, but I didn't end up doing that. So, whoops. All right, but we will have this wireless over here on this side, providing channels to our assembly lines over here. So let's just go ahead and we're going to have our data bank here. So let's just plop it like up here, I guess, on top of the vacuum freezer. And it's going to kind of just go this way. Let me get my wireless thermometer kit, as I like to call it. It kind of just looks like a thermometer, right? And we're going to link it to that one. There we go. So now we are getting a dense cable's worth of channels delivered upon us over here. Yep, 200 AE per tick. I will accept that. And here's how our network is going to be set up. So we're going to need basically a we're going to basically need like an input and an output, right? But we want to be able to provide our recipes to multiple assembly lines. So the way we're going to do that is that we are going to use a point-to-point system to deliver the items to an assembly, and then we're going to use storage buses to put the items into the assembly. So let's get a bunch of storage buses. We will need some fluid storage buses, but we're going to need a lot of item storage buses, like a lot of them. We don't know how to make quartzite plates, apparently. Alright, quartzite plates, quartzite. That's just going to be a compressor. We can multiply the recipe to 4 for parallelization purposes. Compressor. Alright. And then now let's go ahead and get the storage bus. Okay, so this subnetwork is going to receive the items on a what's it called? It's going to receive the items on a dual interface. And then how do we want to send the items back into the main storage? Since we've been having that issue where items don't like to get pushed back through interfaces, I am thinking we will, instead of pushing through interface, I'll just have like an interface dedicated here to receive items. And we can just push the items into it or something. I don't know. I'll figure that out. But let's go ahead and get our stored. Yeah, see right now our assembling machines here are jammed because the interfaces got frozen. I still don't know what causes that, but it is quite annoying. And it makes me hesitant to use that for other reasons. Anyways, so fluid storage bus is good to go, and then we have our storage buses coming up here. So fluid storage bus for you, and then item storage buses everywhere else. And then we are going to be hooking those up. Need to figure out how... I guess normally for this kind of setup, you use a what's it called to do this? Yeah, I'm thinking about this. Don't you have to use a controller? Because this is more than 8 channels. So we'd have to use an ME controller for one of these. Maybe we don't want to automate it like this, because if we automate it like this, we have to use a controller, and that seems not ideal, to say the least. Yeah, let's not do this. Let's not do this, because I don't want to have to make more ME controllers. The controller recipes are... Where are they? The heck are you? Controller test block, okay. ME controller, here it is. Yeah, they're a little annoying to make, to be honest. Block of stellar alloy, we have to use the miniaturization recipe. It would be nice if they made like a recipe, you put controller in it and you get controller out of it, but they did not. So okay, let's not do this then. This is what you'd use in a different kind of GregTech mod pack. Instead, let's just use a buffer. So buffer. How many fluids does the ingredient buffer hold? Ingredient buffer can hold 16 buckets of a fluid. Assembly line can... What's the biggest assembly line recipe? Is it more than 16 buckets? Let me flip through these really quick and find the answer to that. Okay, no, the biggest is actually the creative storage key, which is the end game goal for this mod pack. So that one uses exactly 16, so we're good on that front. We can use these ingredient buffers. Question is, are they better than the GregTech buffers? So this is what the GregTech buffer costs, is a MV pump, an MV conveyor, and then an MV machine hull, and then an LV circuit. These all just use the LV circuit. They're just bigger on the bigger buffers. It also gets 16 item slots, which is enough. This one only has 9 item slots. Ooh. Okay, so that's actually a consideration. If it only has 9 item slots, I think we would need to do the large ingredient buffer. I don't know how much this one holds, though. I'm just gonna science to look at this really quick. It does hold 27 items, but, like, it's considerably more expensive to make this. Like, it needs Enderium, 1K storage fluid, annihilation, and formation cores. Yeah, so let's just go with regular GregTech buffers. And we're gonna need to make the MV ones because we need up to 4 fluids, so this one has 4 tanks. That's why we're gonna do that one. All right, and then I believe we can make these now, right? If I wanted to make like 128. Oh, we don't know how to make system on a chip. Let me go ahead and... I'm pretty sure we know how to laser engrave it, we just don't know how to slice it, so... Cutting. All right, now could we make those if we wanted to? We could. It's just we don't have a big enough crafting storage, and that's fine, because I'm not actually trying to make that many. Let me just make a few for now. Turn off cheat mode also before I give myself another item on accident. Okay, so let's put our buffer, oh yeah, let me delete that one that I spawned in. Let's put our buffer right here on the input hatch, so it's going to receive the items and fluid into the buffer. Here we go. And then the input hatch is going to pull the fluids in, and then we want a way to pull the items into these input buses. So, and the order doesn't matter. So we just need something that throws the items from this buffer into the input hatches very quickly. So let's think about what kind of logistic options we have. Phantom faces, I don't think are good because this is a 1-to-1. So do we need a phantom face for each one of those? Not really ideal. We already ruled out using an AE2 subnetwork because I don't want to make controllers for every single assembly line. Conduits, item conduits are okay, but they're like slow, right? And then you need to make a bunch of speed upgrades. So speed upgrade. We need like not that kind of speed upgrade, this kind of speed upgrade. We need like a stack of these for every single, not a stack, 15 of them for every single one. And that just feels slow. So what I'm thinking actually is, what about integrated dynamics? Use an importer with a bunch of interfaces. And then we can also use that to kick the item out. So that's what I'm thinking here. So let's get some logic cables. So this is how simple this setup would be. Should just be this. And then we're going to use interface. I will need to make a handful of these if I'm doing this method. Let me just make yeah, let me just have one for now. And then interfaces on the input buses. And then we need an importer on the buffer. So importer. And that should basically pull anything that goes in here directly into one of those buses. And we just need to put a, we just need to have this always active. So let me put a variable card into the always active slot. That's just going to always fire true. So now if we put stuff in here, it should start filling it into the bus. Let's test that really quickly by throwing these random items up here in there. Bloop. Didn't put them all in there for some reason. Did I put too many? 1, 2, 3, 4, 5. Okay, I just filled them. That's what happened. Okay, so that worked as expected. All right, so then we just need to put a P2P here. So P2P, and I already have a handful of P2P interfaces. So there's going to be our P2P tunnel to get into the assembly line. Here, let's have a dense cable coming out of this guy. Dense cable. And I don't know how many dense cables we're going to need. I'll just build it out to here for now. So we're going to have a kind of a master interface setup over here. We could actually use our unused... You know what? Let's use our unused P2Ps because I have some under our base down here. So we can call one of these assembly line. Because this is assembler P2P, bending 10. Here's an unused, and I think there's another unused over here. Yeah, there's another unused here because we moved those to the wire mill. So let's go ahead and we're going to take over this one right here. We're going to call this how about I just call it AL? P2P. That's another word for it instead of ASCII AL. And this needs to be set in blocking mode. And we are going to use our memory card here to pick up the frequency from this P2P tunnel. So F298. And we are going to paste it onto this point-to-point right here. And it says Device offline. I don't know why it's not telling me the frequency, though. Can you tell me the frequency? F298. Okay. So now when the assembly line interface down there sends a recipe, it will check all of the potential places for a recipe to pop out here. And then as far as getting the item back into the system, honestly, I think it would be fine if we just had like a input interface here to receive the item back. So let's go ahead and do a interface right here. And that's just going to receive this item back. I will not show it on the interface. And I can hook up a logic cable here. And then the way we're going to get the item out on the same logic cable without screwing stuff up is that we're going to use logic cable channels. Oh boy, more channels, right? So we're going to use an item exporter. That's going to push the item back into the network here. And we also need the variable card. I keep forgetting those. So that's going to push the item in here, and we want it specifically, oh, I forgot to configure that side. We want it to be configured to a specific channel. So I'm going to set this to channel 1 because the other one should be set to channel 0. So all of these interfaces here have a channel. And on the output bus, I'm going to set this channel to interface channel 1. And let me just double check this is still channel 1. Okay, channel 1. So now, if we put an item in here, it should end up in the input bus. If we put an item in here, let's put my memory card in there. Cannot put items in here. Oh. Let me take this out and just test with, like, a chest then. Chest. We can use our slightly larger chest. So if I put my memory card in here, it should get pulled out, sent it to our interface, which should send it home. So let's look at our storage for the memory card. Can't help but notice, okay, the memory card ended up in here somehow. How did that happen? Really confused on how that happened, actually. If I put something else in here, let's put our time in a bottle. Time in a bottle. Ended up here somehow? How is this getting back into there? That makes no sense. Hold on, 1 second. I need to figure out what's going on here. So this is interface channel 1. This is interface channel 0. 0, 0. So these are all 0 because they're like the default channel. How are you... The only way they could be getting the items is if they are pushing it, right? So let me diagnose this a bit off camera. I'll be back once I have this figured out. Okay, I think I figured out what's going on here. So I set all of these to a regular interface, and I think what's happening is that these LV input buses are like sucking on the logic cable, and they are pulling the items out of the other interfaces. So if I just aim these downwards, they should no longer pull on the cable, and it should stop doing that. Okay, there we go. So let me take my items out. Okay, so that's one thing we need to remember. When we set this up, do not have the buses facing the logic cable. Let me put this back over here. We are going to export always. So that should have gone in the first bus it found. That should go in the second bus. Okay. And then over here, I'm going to connect this cable back up, put the interface... Where'd the interface go? Okay, oh, there it is. It's on the floor. I was like, I'm very sure I had an interface. So we're going to put this interface here. And this item should not be going anywhere because this is not connected. And that's on channel 0 as the default, right? Oh, no, this is on channel 1. Let me put this back to channel 0. Now we're going to hook up this cable over here. And put the variable card in there. So this block should still be over here. Okay, so as soon as I set this to channel 1, it should suck the items out of there because that interface over there should still be set to channel 1. So save. There they go. And then let me actually put something in our storage. So time in a bottle. Didn't end up in any of our input buses. Time in a bottle. There it is. Okay, so this assembly line should be ready to go now. Except I need to put the output bus back here. Okay, one thing I need to consider as well is that the output bus also needs to be not facing the interface like this, because I think if I have the output bus facing the interface and an item goes in here, I think it's going to suck it or push it into an input bus potentially. So let me just make sure that's also facing down. Okay, or just not facing the cable. So that should be good to go now. All right, so let's do a test graph then. Let's go ahead and we can do all of our LUV motors, or not LUV motors. I mean, I will do the LUV motors, but let's go ahead and do the LUV assembly first. Okay, so we do not need the data stick. Let me do it in the bigger processing interface here. We do not need the data stick. We do need everything else, though. The order of the fluids doesn't matter. I think I'm going to need to make a few things here. I don't think I know how to make all of these here, so let me put those recipes together really quick. Let me see what we have. So AL P2P. So motor. LUV motor. We need that, that, and that, and that. Kind of a lot of things, actually. All right, so HSS rings. It's going to be in the ring extruder. HSS long rod is going to be in the long rod extruder, believe it or not. The long samarium? Do we have samarium? I hope so. Anyways, this is going to be in the polarizer, and then this is going to be in the long rod extruder again. HSS rounds are going to be... Oh, those are nuggets, huh? Nuggets in a lathe? And this looks highly inefficient. That looks highly inefficient. Okay, so we want to get the nuggets. How do we get the nuggets efficiently? Fluid solidifier and alloy smelter. Well, we have a fluid solidifier with nugget mold in it, so I say we go with this option here. So let me go ahead and fluid solidifier option there. And then we also are going to need to extract it from a ingot. So extractor goes here for extracting the fluid. Nugget solidify for getting the nugget. Then we need the actual round in the lathe. I guess, is there any other use for nuggets? I don't think so. So let's just do this at a multiple of 9. Because we're always going to make 9 nuggets and then turn them into 9 rounds. So lathe for the rounds. Ring mold. Whoops. What's it called? Yeah, L rod is what I called it. So long rod for the long rods, and then polarizer for this samarium. Why do I have magnetic samarium rods in here? Yeah, we don't think we use... Oh, we do use these for the ludicrous coils. Okay. All right, we're just going to leave it at that. All right, now we should be able to... Oh, I forgot the fine Rudet wire. In the wire mill number 3. I still leave the program circuit in there because I didn't take the program circuit out of here, and if I take the program circuit card, it's going to complain. So, and then if I don't put it in there, it's going to set it to circuit 0, and then it's not going to work. All right, let's go ahead and try this again. Samarium ingot. Oh. We have some samarium dust. Where does this even come from? Doesn't come from that. I don't say that much. Samarium dust doesn't come from anywhere? It must come from a small dust or a tiny dust here. Let's look at small and tiny dust. Oh, it comes from rare earth. Ooh. Okay, and then what about tiny dust? Does that come from anything? Nope. So rare earth. Huh? I guess I'm already processing it because we don't have any rare earth and we do have a lot of samarium dust, so. Okay. Is that what this over here is for? Rare earth? Oh, okay. That would explain that. How's our Nakwita doing over here? Just grinding away. Here, let me help out the macerators. Okay. Alright, so samarium ingot then we need to make. So that's just a classic EBF with helium. Oh, okay. So let's go up here. Hot samarium ingot. Whoops. I put the hot ingot in there on accident. There we go. EBF fluids. Alright. LUV motor. Let's go. Let's do this. Please work. Alright, everything's going to be crafting up. It's going to take a second to get everything together, but once everything's together, it should pop over here, and this should start crafting. Because I believe we have everything set up. Ruridet's going to take, like, 30 seconds, right? It's doing the samarium rod right now. So many ingots, and they're, like, expensive ingots, too. So there's the Ruridet finishing up. Now it's cooling down, and should be ready to go any moment now. It's over in the wire mill right now, and it is crafting. All right. And are we crafting over here? We are. Oh, look at this animation. That's cool. And then our item should pop out here, and it sent it back to the interface. It didn't end up in a random bus. Excellent. All right. There we go. LUV electric motor. Why do we not have quest unlocked, though? Oh, we need to get to LUV age first. Okay. Well, that's easy. That is rhodium plated palladium. That is the main metal. And then we need to make that into plates for the... what's it called? Ben C1. We need to make that into plates for the machine block. So LUV machine casing. We're still going to be using the wrench recipe because, like, if it ain't broke, don't fix it. Oh, no, wait. Yeah, that's how it goes. And then we need to turn it into the machine casing. So this now requires PTFE, niobium titanium cables we are good on. I have put it in the non-fluid table as per usual. There we go. I didn't save the recipe. Please just go in there. There. Okay, cool. Assembly. All right. Let us get our LUV machine casing. Machine hole, rather. Oh, it gives us some red garnet. Wow, amazing. When, like, the quest bookmaker's like, I don't know what to make. Here, put this in there. All right, so that is done. We get 100 experience points. Amazing. Red garnet dust. I think that's supposed to go down to our centrifuges. Maybe I just don't have it configured in here. Yeah, it doesn't look like it. There you go. Red garnets, away with you. All right. Well, we are now in LUV age, kind of. So what I'm going to be doing next time is setting up, probably doing the rest of these components here, and then I will work on... We can already do LUV circuits to do the bulk LUV circuit quest. I'm just going to do it right now, because we can. But yeah, I'll finish setting up the rest of the recipes for the pumps, the conveyor belt, the piston, and the robot arm. And then... I will try to figure out what we're doing. Probably we're gonna have to then work on upgrading our assembler because we are going to be in the LUV age with LUV machines, and we are going to need to make like a LUV energy hatches. And to make LUV energy hatch, guess what? It's in the assembly line. Woohoo! So we'd need the data stick for the LUV hatch, and that would be I think it's just an IV energy hatch, right? Yeah, IV energy and dynamo. So we'll need to make that. We will need to just do all sorts of fun things, right? So yeah, I'll just be probably working on setting up the rest of the assembly line. I'm not going to build another assembly line until we have our data bank set up, and I'm going to do that one on camera. So until then, thank you for watching. If you enjoyed the series, please leave a like, comment, subscribe, and I will see you next time. Goodbye.